Learn Lagrange interpolation. We use interpolation to find the functional values within a given interval or a given domain. The opposite of interpolate is extrapolate. We will only learn interpolation during this semester. We will learn two techniques. The first technique is called Lagrange interpolation. The basic definition of Lagrange interpolation is given here. We remember that f of x stands for the y values. For example, if I substitute x naught here, I will get f of x naught, which is y naught. If I substitute x is equal to 10, I will get f of x 10, that is y 10. All right. So the data will be given to you. How many values will be given to you? Let's say if 10 values are given to you, you will write a polynomial of order 9. Remember, the Lagrange interpolation formula is actually a polynomial, and the order of the polynomial is always one less than the number of data points. For example, if a linear interpolation is desired, this is called the linear interpolation polynomial. The order of this polynomial is 1. For example, you can see the power of x here is 1. Okay, and how we derive this formula? Remember that two data points will be given to you, x naught, y naught, and x1, y1, or x naught, f of x naught, and x1, f of x1 will be given to you. The first term of the formula is for f of x naught. The second term of the formula is f of x1. You will multiply it with the fraction x minus x1, x naught minus x1. If you are using x naught here, you will write in the denominator x naught minus x1. Next, go to the next term. You will have a term with f of x1 multiplied with the fraction x minus x naught, x1 minus x naught, because only two data points were given to you, x naught and x1. Therefore, you can see that here for the first term, here you had x naught as the subject, so you multiplied it with x minus x1, x naught minus x1. Here x1 was the subject, so you have multiplied it with x minus x naught, x1 minus x naught. All right, so remember this strategy to write a interpolation polynomial. Let us understand it more with the help of a quadratic interpolation polynomial. Here you can see that we have f of x naught, f of x1, f of x2. This is called the quadratic or the second order interpolation polynomial. For this polynomial, three data points will be given to you, x naught, x1, and x2. And of course, for these values, you will be given f of x naught, f of x1, and f of x2. Now, students, for the quadratic interpolation polynomial, three data points and three functional values will be given to you. So your polynomial will have one term with f of x naught, one term with f of x1, one term with f of x2. For f of x naught, you will multiply it with a product this time. For the linear interpolation, can you see here, it is a single term. For the quadratic interpolation, you will have the product of two terms, x minus x1, x minus x2. Why, students? Because x naught is the subject, so the remaining 2 points are x1 and x2. Only 3 input points were given, x naught, x1, x2. So if you have kept x1 as the subject, therefore you have x1 and x2 remaining, so you will write them product x minus x1, x minus x2. And can you see, if you multiply these two and open the brackets, the order of this polynomial will be x squared minus some constant times x1, x2, x, and then another constant. So this is a quadratic or a second order polynomial. Okay, now in the denominator, because x naught was the subject, so instead of these x, you will substitute x naught, x naught. Next, x1 is the subject, so what are the 2 points remaining? X naught and x2. So you will write x minus x naught, x minus x2, and then x1 is the subject, so in the denominator, instead of x, you will substitute x1. So this is the strategy, key strategy to memorize the interpolation polynomial formula. And then once you learn this strategy, you can even write a fourth or fifth order polynomial very easily. So what is the strategy? If 3 data points are given to you, write 3 functional values, the sums. X naught, x1, x2 were given to you. So you have written here f of x naught, f of x1, f of x2. You have multiplied it with the, if 3 data points, then 2, a product of 2. If 4 data points, then a product of 3. and if two data points, then a single one here. Okay, so now you can see that here f of x naught is multiplied with x minus x1, x minus x2, and so on. We can also go to the cubic polynomial later. Let us go through some examples to understand the interpolation, although it looks quite difficult, but when you use some data and implement interpolation polynomial on that data, you will find it very easy. Okay, so this is a table of homework number 1 for the upcoming week. I have made a table. I have said that the order of the polynomial is always 1 less than the number of the data points. You will tell me what we call a 3. If I have 3 as the order of the polynomial, what am I going to call it? You will write here. For example, for 2, I call it quadratic. So similarly, how many data points are desired for a polynomial of order 3? And how many data points are desired for a polynomial of order 4? You will tell me. You will make this table as the first question of your homework for the coming week. Now, this is a very nice picture, nice pictorial depiction of the interpolation. Can you see here? You have 2 data points here. This is a linear interpolation. You have 3 data points here. You have a cubic interpolation. You have 4 points here, 4 data points here. Okay, so you can see here, linear, quadratic, cubic, and 4th order. Okay, I repeat, linear, quadratic, cubic, and 4th order. All right, so now let us go to an example. Now I have asked you to find the functional value at 4. Let us look at this data first. What is happening in this data? 1, 2, 3, 5, 6. I can see data is not equally spaced. Equally spaced means that 2 minus 1, 1, 3 minus 2, 1, then 5 minus 3, 2, not 1. So the data is not equally spaced. Okay, so I can apply Lagrange interpolation, but not some other methods. Okay, so now we will apply Lagrange interpolation, and the question is that find the functional value at 4. Okay, so what am I going to do? I need a polynomial. Now they have already described here that use a Lagrange interpolation polynomial of order 1. By order 1, it means a linear interpolation polynomial. By linear interpolation, it means I need 2 data points and I want the functional value at 4. I can see 4 is somewhere here. So I will pick the neighboring values and I will keep in mind the meaning of the word interpolate within a given interval. So that is why I will pick 3 and 5. So you can see here I have selected 3 and 5 and the functional values are given to me. This is x naught, this is x1, this is f of x naught, this is f of x1. I have my formula ready here. I will substitute the data in this formula. I will simplify it. I will get a polynomial. Okay, and this is the reason that I've already explained it to you. And now always solve the question in 2 steps. For the sessional 2, for the terminal, for the assignments, always solve it in 2 steps. First, give me the polynomial, then substitute x is equal to that unknown value, the functional value. This functional value is unknown. So substitute x is equal to 4 here and then simplify it to give me the functional value at 4. Okay, so now this is the first example. Okay, what have I done in this example? Data was given to me. They asked me to find the functional value using the Lagrange interpolation polynomial of order 1. First, I will write the formula for the Lagrange interpolation polynomial. Then I will substitute. Then I will wisely select the data which will actually interpolate 4. Then I will substitute this data into this formula. I will simplify it and I will write a polynomial. You can easily see it is a linear equation and a linear polynomial. Now if I want to find functional value at 4, I will simply substitute x is equal to 4 here and I will get the answer. Now repeat the same process and I have already selected the data for you, the closest data which will give you better results with better accuracy. Now please find f of 4. Repeat the same process but apply the quadratic interpolation. Got the point? Now this is the second question for the upcoming assignment. Now let us go to another example. You can see here the data is given to you, 4 data points are given to you, and the data is of course unequally spaced. You can see 6 minus 5 is 1, 9 minus 6 is 3. It should be 1 everywhere, or it should be 2 everywhere, or 3 everywhere if it is equally spaced, but here the data is unequally spaced. Okay, now you can see here, students, that you have here the x values given to you, y values given to you, and the polynomial given to you. Let us multiply these 3 brackets together. We will get a cubic polynomial. Okay, so the third order polynomial. Okay, so now you will substitute the data, simplify it, you will get a polynomial. This is the step 1. And now let us say that someone has asked us to find the y value at x is equal to 10. All you need to do is, in this formula, the last formula, you will substitute x is equal to 10 and simplify it, do the algebraic manipulation and simplify it to find 14.663. This was quite easy. Okay, now you will solve a quadratic polynomial. This is a homework, part 3 of the upcoming homework. Okay, the data is given to you and I want to find the output in thousand turns in the year 1986. Where is 1986? Somewhere here. Okay, and if I have asked you to use the highest order Lagrange interpolation polynomial, by highest order I mean to say that go for the highest order possible from these data points. So you can see 4 data points, so of course the highest order polynomial is cubic. All right, got the point. So now find the polynomial and then substitute x is equal to 1986. Always follow the same steps as I teach you in the video. Okay, now submit the homework by 9th of November. Okay, you can submit late assignments, but definitely first come first serve basis. Okay, so if you submit the homework timely, then I will definitely keep checking my CEO online and I will give you better grades. Okay, so good luck and thank you.